And now I want to jump to show you this analogy with natural ecosystems with an industrial ecosystem. Industrial ecosystem is a recent a concept that has been going on. It's just to show you. I mean, again, in our case, we take source resources, materials, for example, mining and extraction. We go to smelter and generate goods, let's say gold, copper, aluminum, whatever thing. We manufacture, and this is very important, we deliver. As soon as we deliver, we're putting energy there, we're wasting resources. So logistic is a very important issue here in order to reduce this ecosystem. Imagine a natural ecosystem, let's say a lion asking for Amazon for meat. Can you imagine that? I mean, or even us, I mean, asking Amazon to send something from China to have something that it costs less than $1, I mean, it's crazy. So one of the things is the logistic to produce in near your town. Very simple. And then they deliver the product, it's being consumed, you generate waste and landfill and let's say aquifer. And you have these 3 R's for recycling, reducing waste and all this stuff. And some of them come back, let's say electronic scrap. Most of them can be recycled. But unfortunately, just to recover copper, and by the way, I visit plants in Croatia, they reduce, they have electronic scrap, but they are selling this dust only for copper. But we know that in England, in Germany, and even in France, they take more elements, but it's a secret. So, I mean, recycling electronic scrap, a very good business. And again, we need to have more chemistry, more processes. I visited the plant in Croatia. I saw the dust, and I know the owner of the plant. It's kind of disappointing, very disappointing, because let's say they recycle these laser printer cartridges, which contains carbon black. They produce carbon black from recycled cartridges, even a better standard than from a new black carbon. However, believe it or not, in Europe, the regulation from the European Union does not allow you to use as a raw material that coming from recycling. So how clever is that? So again, policy is completely wrong. Imagine that. So they generate carbon black that can be reused. However, they end up landfilling these elements. Again, because only the policies. Stupid. So the idea that I want to show you is you can use this analogy for environmental ecosystem for an industrial. So how can we improve that? In the same picture here, and you can see the distribution disappear. You don't need, you need to have more local plants, more production in your own country, your own community. Okay, imagine that. More, you boost the economy, by the way. Imagine what happened. I mean, just the solar panels. I mean, Germany bankrupt a company that produces solar panel, and now you are sending solar panels from China to Germany. Imagine the footprint, the CO2 footprint, which, by the way, is 3 years. I mean, if you buy a solar panel, you can. I mean, you are not being environmentally friendly up before. I mean, until 3 years, because to build this solar panel, you use a lot of elements. The carbon footprints of a solar panel in 3 years. So in the 3rd year, you start generating clean energy, not the first 3 years. So imagine that. Nobody knows that. So imagine if being shipped from a different country. And again, here you make more efficient this. Look, this is a different thing. I will ask you to compare this plot with this plot. This is the reuse of parts. You don't need to recycle. This is remanufacturing. I remember working for a Japanese company. We did a master degree thesis for a person who works in a Komatsu. Komatsu is a Japanese company. They remanufacture all these big mining trucks. Imagine, I mean, huge big trucks. So we don't have a way. I mean, I should write a paper on that. So it's more efficient to fix and remanufacture the wires of an electrical motor rather than buying a new one. So remanufacturing is very important, especially you guys, mechanical engineers. It's very important. I mean, the carbon footprint for to generate a metal. Imagine an axis. What do you say? A shaft. I mean, this big, is huge. The carbon footprint. So this is a new way to see the things. So that's the type of thing that, I mean, the way to see, regardless the process, can be car manufacture, can be solar panels, hydrogen fuel cells, whatever system that you have, you can have this approach. I really like it. I really like it. And to end up this class, because we have 20 minutes remaining, I just want to conclude some remarks here. This is the cover page of sustainable engineering. I mean, those are, I mean, the checklist that we need to go through. How good are we in this? I like it because it sums up all the things that we should be checking the